Hi everyone, welcome to the channel. Today I was able to find a really fun trig integral for us to tackle, and let's dive straight into it. Cool, so here's the integral, and I'm just going to wait a moment or two for anyone who wants to try it to pause the video. Cool, so let's get straight into it. So firstly, there's more than one way to solve this integral, and there's one way using a substitution, u equals cos x. Which I'm not going to use, but if you want to try something different or challenge yourself, or you've done this method, then yeah, there's nothing wrong with that. But let's go into another way of doing it. So the first thing I'm looking at is that the denominator is really quite awkward, 1 minus cos squared x. So I want to use this identity here and rearrange it to produce this, so that I can substitute 1 minus cos squared x for sine squared x. And this is just an identity you kind of have to know, but just in case you don't know it or it's new to you, there's a really nice proof with a right angle triangle, which is if you have a triangle with the hypotenuse being length 1, then this side will be cos x, this side will be sine x, and you can use Pythagoras' theorem to say a squared plus b squared equals c squared, where a squared will be sine squared x and b squared will be cos squared x. And this will equal c squared, which is 1 squared, which we know to be 1. Cool. So now we know that 1 minus cos squared x is sine squared x. We can just sub it in. And we can write tan x as sine x over cos x. And now we can simplify, because we have sines on both the denominator and numerator. So we can just write it like that. And all I've done is cancel out these signs with one of these signs. Yeah, perfect. And now I want to write this all as one fraction because it's really quite awkward if I don't do so. And I can use the same identity we used earlier to sub out 1 minus cos squared x for sine squared x. Just like that. And now we just need to be a little bit careful with our fractions because we have two fractions, but this is sine squared x over cos x all divided by sine x, which means that we can cancel out one of these sine x's with the sine x down here to make it sine x over cos x, which is just tan x. And some people may just know that this integrates to ln sec x, and if so, feel free to skip to the end of the video to see the solution. But just in case you don't know, we can go through it together. So actually the first step to integrating tan x is to write it as sine x over cos x. And the reason why is because you can take advantage of this really cool formula, which is if you have the derivative of a function over a function as in an integral, you should be able to times it by some kind of constant to produce a natural log of that function. And this is really handy because when you differentiate cos x, you get minus sine x. So you can see you have minus sine x, the derivative on the numerator, and cos x, which is the function on the denominator. So we just now, if we can solve for k, then we can express the integral. So the way to do that is actually to work backwards. We're going to try and differentiate ln cos x because we know that that's our function. And we can do so by setting y to equal ln cos x. And actually using a technique called chain rule, which requires adding in an extra variable in between y and x because it's a bit complicated. So if we set u is equal to cos x, we can then sub in u here. So all I did is sub out this cos x for u, so our y is equal to ln u, and that means it's a lot easier to find the derivative of y in terms of u. It's just 1 over u. dy over du is just 1 over u, and du dx is equal to minus sine x, which we said over here. And now maybe you can also see why this equation holds true, because we have 1 over our function and we have the derivative here, and we can just simply multiply them to get dy over dx, and the du's will cancel out, so then you end up with 1 over u times by minus sine x. And so this means dy dx is minus sine x over cos x, which is minus tan x, and that's not quite what we want. We want to integrate tan x, but we can see then that our constant has to be minus 1. Because if you times by minus 1, you'll get tan x. And that's really important, so we can put a box around it. And then we can rearrange this this expression here to move this k to the other side. So if we divide both sides by k, you get 1 over k ln cos x. And all we have to do is sub k in. Perfect. So now we have minus ln cos x. And we can take advantage of one of the log rules, which is you can if you have a coefficient of a log, you can put that in as a power. So minus ln cos x is equal to ln 1 over cos x, or cos x to the power of minus 1, which is just ln sec x. Keep in mind also, both of these are valid solutions as well. You can use these. It's just in mathematics, typically we tend to use this function, sec x. But it's literally just 1 over cos x. So yeah, if you don't know that yet or something, feel free to use any other valid solution. Cool, so now we're here. It's really quite simple after the hard work we did. So we can just sub in pi over 3 here and 0 here. So ln sec pi over 3 minus ln sec 0. And sec pi over 3 is 2, and sec 0 is 1. And any natural log to the power of 1, any natural log of 1 will always equal 0. So this cancels out and we're just left with ln 2. And that is our final answer, so we can put a box around it. And that is the answer. I hope you guys enjoyed the video, and I look forward to seeing you guys next time.